Before an AI agent touches a wallet or smart contract, we need evidence that it behaves safely. In this section, we'll test tool calls, transaction logic, policies, attacks, and edge cases, so deployment feels controlled, not hopeful. So far, you've seen how agents reason, use wallets, call contracts, move value, monitor events, and operate autonomously. Now we shift to testing, showing that these systems behave safely, consistently, and transparently before they reach production. Testing a normal app often means asking, given this input, did we get the expected output? Blockchain agents add new dimensions. Their responses may vary, so we test behavior, boundaries, and refusal rules. Because they can connect to wallets, mistakes can become irreversible transactions. Before anything is signed or broadcast, the agent's reasoning, tool choice, permissions, and transaction details all need to be validated against both helpful requests and hostile prompts. A reliable agent is not proven by one successful demo. It is built through layers of evidence. Start with cheap, repeatable unit tests for tools, policies, and validation logic. Then test the connections between the agent, wallet, RPC provider, and contracts. Add adversarial cases that try to manipulate intent or bypass safeguards. Before Mainnet, rehearse on forks, testnets, and staging environments. Finally, production monitoring turns real behavior into feedback for the next test cycle. Each blockchain tool needs isolated proof that it behaves correctly before real funds are involved. Unit tests provide that proof without relying on live networks. Mock the RPC, feed known wallet inputs, and assert exact outputs, formatted addresses, supported chains, selected accounts, balances, and contract return values. For payments, the critical boundary is clear. Preparation creates an unsigned transaction object, not a signed transaction. Tests enforce safety before autonomy begins. Guardrail tests prove the agent respects boundaries before money can move. Check spending limits across tokens, chains, wallets, users, and time windows. Confirm restricted actions are blocked before transaction construction, not after signing. High-risk operations should require explicit approval, and sometimes more than one confirmation step. Also test refusal behavior for clearly prohibited requests, like draining a wallet or bypassing limits. Whenever possible, keep these tests deterministic and independent of the language model, so policy enforcement is reliable and repeatable. Mocking turns blockchain testing into a controlled lab. Instead of calling a live RPC, the agent receives scripted balances, blocks, receipts, and contract reads. Instead of real keys, it signs with fake accounts. This also lets you force the ugly cases: downtime, gas estimation failures, reverted calls, bad ABIs, rate limits, and chain mismatches. The key is determinism. Fix timestamps, gas values, and responses, so each test fails or passes for one clear reason. Adversarial prompt testing asks a simple question: can the agent stay loyal to policy when the input lies? Include messages that pretend to be developers, auditors, wallets, or contracts. Also test hidden instructions inside token names, NFT descriptions, DAO proposals, and contract fields. Then try high-risk actions like bypassing spending limits or chain rules. A passing agent refuses unsafe requests, preserves confirmation flows, and escalates ambiguous cases to human review. A useful adversarial test suite is not just a folder of clever one-off prompts. It is a reusable system of attack categories: prompt injection, social engineering, malicious metadata, and policy bypass. Test direct user requests, but also indirect content from on-chain data or API responses. For each case, run phrasing variants so the agent cannot overfit. When it fails, capture the example, expected behavior and severity, then turn it into a regression test. Treat every prepared transaction as untrusted output until it proves it matches intent. Check the recipient, token, amount, decimals, and chain ID. Then verify gas, nonce, deadline, slippage, and transaction type. For approvals, swaps, transfers, escrow deposits, and contract calls, confirm the required permission state first. Most importantly, the transaction should remain unsigned until every validation and user approval has passed. Signing is the point of no easy return. Token approvals deserve focused tests because they can silently expand what a protocol may spend. For a swap request, safe behavior means recommending only the needed amount, not unlimited access, and naming the exact spender contract. Tests should also catch suspicious addresses and existing high-risk allowances. When the chain requires it, approval and swap should be separate transactions, so the user clearly approves permission before value moves. Integration testing is where the agent meets the real transaction path. Use testnets to exercise preparation, signing, broadcasting, and receipt monitoring without risking funds. Use local forks when you need mainnet-like state, existing contracts, and repeatable failure cases. Deliberately trigger reverts, insufficient balances, and gas spikes. Then confirm that policy checks, tool calls, wallet actions, and receipts are captured in logs. If something breaks, the audit trail should explain exactly why. Evaluation should measure both sides of agent behavior, doing the right thing when a request is safe and stopping when a request creates risk. A strong scorecard tracks correct tool use, transaction accuracy, policy compliance, refusal quality, and user explanation. Watch for false positives, where useful requests get blocked, and false negatives, where unsafe actions slip through. The best refusals are clear, consistent, and educational, but they do not reveal instructions that help someone bypass safeguards. CCD turns testing into a release gate, not a checklist afterthought. Every commit should trigger fast unit and policy checks. Before staging, run deeper integration, fork-based, adversarial, and transaction validation tests. If a critical safety or refusal test fails, the pipeline stops automatically, preventing risky changes from quietly moving forward. Just as important, store results with logs, audit trails, model versions, and prompt versions. That creates evidence for debugging, compliance, and confident releases. The core takeaway is simple. Trustworthy agents are tested at every boundary. Verify tools, challenge prompts with adversarial cases, and validate every transaction detail before signing. With that safety foundation in place, you are ready to study deployment patterns, then bring everything together in the capstone autonomous Web3 agent.